Hey folks, welcome back to the channel. Today we'll be covering the problem removing digits. Let's go over the problem first. So the problem states that we have been given an integer n, and on each step we can subtract one of the digits from the number. We are tasked to find the minimum number of steps which we will need to make this number equal to 0. Let's look at the example test case first. We have been given the number 27. So, what would be the possible number of steps that you could make from here? Well, you can either subtract 2 or you can subtract 7. In the optimal solution, we subtract 7 and reach the number 20. Now, suppose you reach 20, the numbers which you can subtract are 0 and 2. Since subtracting 0 will give you the same number, we of course will not consider 0 if we get it. So, the only reasonable choice is 2. We'll reach 18. In the optimal solution, we'll subtract 8 and reach 10. Here there is only one option, which is to subtract 1. That way we'll reach 9, and from 9 we'll reach 0. So I hope the problem is pretty clear. And the number of steps we took are one from 27 to 20, second one from 20 to 18, third from 18 to 10, fourth from 10 to 9, and the last one was from 9 to 0. So the problem is pretty straightforward. Let's go over the logic and see how we will solve it. Well, we keep coming back to the first problem which we solved, which was dice combinations. I'll link this problem to that problem, and then the solution which I have written here will make perfect sense to you guys. Suppose you have been given a number and it has k digits. Since the constraints on the number are that the number can be from n from 10 to the 6, the number of digits a number can have at max are 7, which will be the case when n is 10 to the 6. So suppose the number has k digits. These are like the throws of the dice which you can get when you are at the number n. Or if you are more comfortable with the minimizing points problem, then these are like the number of points which you have at that particular step. So then if you try to map this problem to that problem, this number and the problem becomes pretty simple. In that problem, what we did was as follows. Suppose you can already make a sum of n minus di and you add di to it, then the problem will be solved because you will get the sum of n. Here we are trying to sort of do the reverse of the same problem, which is that we are trying to go from n to the number 0. So if you have, say, a coin di, you will subtract it from n, and the number of ways or the number of steps which you will take for n minus di to reach 0, your n will take one more step than n minus di, because subtracting di will consume a step, and hence answer of n will simply be minimum of answer of n and answer of n minus di plus 1. Now the base case of the problem is pretty simple. If the number is already 0, then we need not make any subtractions, and hence the answer is 0. I'll point out that the solution is not the most optimal. The optimal solution requires you to subtract the maximum digit at every iteration, and then you don't even need dynamic programming to solve it. But since we are solving the dynamic programming section of CSES, I thought I'll make the solution more consistent with the ones that we have seen together. So to ensure a consistent understanding and logic building. Let's now move on to the code and see how we will code this. So here is the solution. We take the number n as an input and declare a DP array with each value being infinity initially. Now infinity in this case, I have set it to 10 to the power 6 plus 1. because this is a strict upper bound on the solution which we can get. Suppose the number is 10 to the 6 and you subtract 1 from it at every move, even though it won't be valid on all the states. But for the argument's sake, let's assume it. Then you would need 10 to the 6 moves to make the number 0. So if we add 1 to it and get 10 to the 6 plus 1, this should be a strict enough upper bound for all the solutions which will be valid. So we initialize every element in the DP array to this number. We set DP of 0 to 0 as explained earlier. Now we simply iterate over the various digits which we will get from 1 to n, get the single digits from that number on which we are iterating, and then simply update the DP state as discussed. So DP of value can be either the minimum of DP of value or the value which we get by subtracting this digit plus. Let's now try to submit the code and see if it passes or not. Let's submit the code and it gets accepted. So as I mentioned earlier, this is not the most optimal way of solving it. You can subtract the maximum digit present in a number at each iteration and you will get the answer regardless. But that won't exactly be teaching you guys what this section is really about, which is solving similar sub problems and storing the result of smaller sub problems to solve something bigger. That's why I decided to go ahead with this solution. But I would encourage you guys to solve the problem that way as well, and submit your codes following that approach too, so that you can have sort of a proof of concept per se. So thank you all for watching the video. Like, subscribe, and share. And do comment whether you understood the solution or not. So thank you all. I'll see you soon.